Let's deep dive into the solution. This tutorial is a continuation of the Wordle engine I discussed in another video. In that video and the article combo, I went over the Wordle engine that checks for duplicates. If you're curious to discover the code behind that part, hop over to the link shown here and watch that first. This solution consists of three screens and a container object. The main screen is the gameplay screen. You get a 6x5 grid into which the guesses appear and the outcome of the game is shown, as well as a keyboard made up of 36 characters together with the delete and enter keys. The design, as well as some neat tricks to ensure that every box has the same properties, was based upon the work of April Dunham. I am sharing a link to her YouTube channel. She has two videos that go over how she designed the interface for her version of Wordle. We also have an About screen that explains how to play the game. Note that in this variation of the game, words need only be at least 3 characters long. The remaining characters are spaces. The last screen is the settings screen that has a single toggle to switch between light and dark mode. April discusses this toggle in her video. I also include a few link controls with links to my online presence. Besides the screens, every power-up app has an app object. The start screen event refers to the screen that is invoked when the app is run. Formulas contain main functions, more on these later, and the onStart event is used to initialize the variables used in the program. In Power-Apps, the screen is called after all the code in onStart has executed. This means that if there are actions that necessitate considerable processing, the app start screen will take long to show up. On the other hand, functions in the formula section are called from within code when required. If we go over the onStart code, we observe that we set the theme, make the question mark and gear icons visible. This is not necessary per se, since the initial setting is programmed into the control. The reason why I opted for this approach is because when one stops power up, it retains all state, and if the play control is clicked, it continues from that state. While being useful, I found it problematic and had to right click on app and choose the option Run on Start to reset the system. It would be great if there were two play controls, one that continues from the current state and one that simulates running the app from the very start. Key variables are gvar row, gvar call, and gvar word of the day. The first two point to the element that will receive input. We have 6 rows and 5 columns. gvar word of the day holds the word that needs to be guessed, and we will go over it further down. One of the limiting factors is the inability to manage variables within a loop. There are two sets of 30 lines of code that could have been condensed into 2 lines if looping with variable updates were possible, and readability would also have benefited. Funnily enough, Copilot suggested the commented code, which I decided to retain. Had the suggestion worked, it would have been great, but sadly, even Copilot couldn't manage to nudge power-ups to go efficient. In fact, as you can see here, it has generated this in real time. And if I say except, we get non-functional code. In an ideal world, there would have been 2 loops, one looping over the rows and an inner loop over the column, in which using an evaluation function, which I am naming eval, would allow one to dynamically address the variable. Better still would be for power-ups to support arrays or list data structures that could be addressed within looping constructs. When one has to perform the mundane task of repeating code, one ends up copying and pasting and then making changes to the row and column reference. The likelihood of making an error is enormous, and many of these errors are runtime errors that break the logic, not the code. Couple that with the fact that one has no built-in ability to observe context and global variables when the code is executed. Debugging becomes very challenging. The best workaround I could achieve is the method that was used many years ago to have labels into which one would output the contents of variables that one wanted to monitor. In order to avoid altering the code every time I wanted to show or hide the debug code, I added a variable called gvar debug that, when set to true, would show the controls and update them. Otherwise, they would be hidden. As you can observe, here we have the row and the column, and this allows us to monitor their value. And we also have another label that is showing the word of the day. While the intended use is for debugging, you may want to implement a cheat mode in your game. Say, if you enter a string in one of the guesses, the word is displayed. That's an exercise for you. Moving from OnStart to formulas, a portion of the code here has been covered in the video, article, and Git repo I created about the Wordle engine. I won't go over it here, but there's a link for anyone who would like to check that out. We have two records that describe the light and dark themes. You will notice that certain colors are identical to both. The idea here is to allow for future customizability. If, for example, you wanted a different variation of green when it's light and when it's dark, all that is required is to plug in the new values here. This builds futurability into a solution, and when it's done early on, at the design stage of a project, it is relatively easy. Planning a project before going into development has its benefits. The next function is called named formula word of the day, and it returns a 5-character string that will be the guess word for that day. The words are not that imaginative, but this is something simple to adjust. We compute the day number from the beginning of the year by taking the difference between the current date and the 1st of January of that year. We then use a switch command to select it. A catch-all check in the switch command helps for leap year situations. Since some of the words are less than 5 characters long, we append spaces to the end and left trim the resulting string so that it ends up being 5 characters long. This ensures that if anyone makes a mistake, it doesn't break the solution. Something that could be a nice enhancement to PowerUp's IDE would be a feature to collapse a function. It would protect the function from accidentally being changed and would visually compact the code. Practically identical to the word of the day function is the link of the day function. Here, rather than the guess word, a string is returned. At the end of the game, the string is displayed in a label or link control in the endgame container group. Interwoven with links that are related to me are lyrics from the song My Fair Lady from the 1960s musical. I ran out of strings to return, and from the 156th day to the end of the year, the same string is returned. Let's go over the gameplay with debug enabled. I select Run on Start option in App to initialize the variables, and I enter a string. As you can see, I have the word of the day and the row-column combo updated as the game is running. If I press delete, the column decrements. This would not be necessary if one could watch variables. There are checks within the logic associated with the delete button press to only reduce the column when it is within the acceptable range. The first guess did not return any matches. I know this from the string that appeared in the middle debug label. If I enter Y46 and press enter, the debug label gets populated with the string YYBBG. This represents the color of each box. This is the output of the NF result function. If I now enter DY47 and press enter, the debug box that held the output of NF result returns the string of the day, and the endgame container appears with the confetti, messaging, and under the Tell Me More label, I show the text. One might ask, why not add yet another label to show the string of the day? I could, but screens become noisy when there are more debug controls to manage. This is another case to justify why having the option to watch a variable would be much more efficient. These could be grouped in the monitor window of Power Apps' App Checker. Let's stop the game and go over the buttons. Let's look at the logic behind the onSelect event of button M. There are checks to ensure that the code body only triggers if the row and column are within range. For example, the endgame code sets the row to 7, effectively disabling the buttons. Here we have a switch within a switch. The outer switch selects the row, and within each row the second switch identifies the column. The global variable associated with that particular label in the grid is set to self.text property. The self.text property of each button is the letter itself. At the end, I have the debug code that updates the position on the grid. This same logic is used for every character. So we have 36 identical blocks of code. To make a change, one has to manually repeat the code change over and over and over again. And one can't even use the search and replace function because this only operates on a single block of code, the one that is on the screen. These limitations prohibit solutions from growing. I experienced situations in this code where I would have liked to program an enhancement but decided not. The idea of spending half a day to do it and the knowledge that as the task becomes more mundane and mind numbing, errors are going to make their way into the solution made me give up. If this code could be stored in a named procedure module that does not need to return a value, a single code base would have been shared by all 36 button routines. In my article and video on the Wordle engine, I suggested a macro-based solution to avoid repetitive code. That alternative is a viable one and would necessitate less core changes since the macro could be logically substituted into the respective location where it is invoked during execution. The better alternative would be one in which Power Apps introduces routines that do not need to return a value. As with macros, these could take parameters, making them more dynamic. Imagine one would highlight all of this and cut it. One would go to a section called Routines under the app object, and after providing a name and parameters, the code is pasted there. Every one of the buttons would simply point to this module. During code execution, similar to what happens with named functions, the routine code is executed, altering variables, be they global or context, and at the end pass control back to the instruction after the call. Let's look at the delete key. It's checking the global variable, storing the column, and provided it's greater than 1, will replace whatever is in the global variable associated with the cell with a space and decrements the variable. The debug code gets updated as well. The last key on our keyboard is the enter key. This button is where all the action takes place. We first concatenate the characters of the active row into the guess word. In this version, the minimum word length is 3 characters. If the trimmed length is less than 3, we simply do nothing. If you want to change it to a traditional game, you need to change this line. We then call NFResult function, passing the word of the day and the guess. It returns the color coding of the 5 blocks which we split into individual variables. When this block terminates, the label's background is changed to the correct colors. Moving on, we check for a match. If this is the case, we set the row to a value greater than 6, recall the logic we had in the buttons, and set the game state to 1, and set the environment to show that the user has won. Otherwise, we increment the row, we set gvar1 to false, and the game variables to those that will be displayed when the game is not won. If the row is greater than 6, it means there are no more rows. The game is finished. We copy the link of the day into a context variable, update debug code, and start the process of setting up the endgame. We hide, about, and set up icons. If the player did not win, we animate the labels and show the word of the day. For the link of the day, if it starts with https:// we place it in the link control, otherwise we place it in a label control. The link control allows a person to click the link and have it open in a browser. And finally, we show the endgame group that groups within it the controls that need to be shown at the end. That is in this container. And if we play the game and enter the correct answer, the container appears with the confetti and text you won, tell me more, and the link or text of the day. When using overlaid objects, be careful about their order. If you have a button or a link that receives input and it is covered by another control, it will not receive that input and fail to trigger. You therefore need to move the object to the top. This summarizes the this, that, and maybe the other Wordle game presentation. If you like this video and find it useful, please like, share, and subscribe. It helps the channel and encourages me to produce more content. Thank you and take care.